Hello everyone, I'm Yusuf Yiğit Korkmaz. I'm a sophomore computer science student in Bilkent University, and this is my Physics 101 project. My project aims to calculate the rotational kinetic energy of a rolling cylinder in an inclined plane. And here are the equipments I'm going to use in this experiment. An inclined plane, a cylinder, a ruler, a balance, and a timer. Here is my project setup. First of all, I used one vertical wood block with height 50 cm. Then I used another plane with 1 meter length. By placing plane in a way that it constituted a perpendicular triangle with another block. By doing this, I got 30 degrees slope. As a cylinder, I used the wooden object with 0.03 meter radius and 0.3 kilograms. In experiment, I dropped the cylinder from the top of the inclined plane, and while doing this, I recorded the time. And I repeated the experiment 3 times in order to lessen human-based errors and get more accurate results. Finally, I have the information of the total distance taken and how long it takes. Since the object moves with constant acceleration, I am able to calculate the average velocity and the average angular velocity. After measuring the mass and the radius of the object, I am able to calculate the moment of inertia of the cylinder. Therefore, using the relevant equations, rotational kinetic energy can be calculated. And we can calculate the linear kinetic energy using average velocity. Summing these two energies up to the total kinetic energy at the bottom of the inclined plane as 1.22 joules on an average. Initial potential energy of the cylinder was calculated using potential energy formula, which gives us the 1.47 joules, where h is the height of the inclined plane. The experiment explored how a rolling cylinder's potential energy is converted into linear and rotational kinetic energy, demonstrating the principles of energy conservation. The results generally matched with the theoretical expectations, but some energy loss occurred due to factors like friction and air resistance. On average, the observed total energy was about 16.6% less than the theoretical potential energy. By including rotational motion in the analysis, the experiment provided a more complete understanding of energy distribution compared to simpler approaches that only consider linear motion. The potential energy at the top was higher than the measured kinetic energy at the bottom, highlighting these losses. Errors were likely caused by limitations in timing measurements, slight inaccuracies in radius measurements, and energy loss to friction and surface imperfections. While these factors influenced the results, improvements such as more precise tools and reducing friction could decrease the errors.